Good afternoon, everyone. Thanks for joining us for this webinar series. We have a distinguished speaker today amongst us. Let me first introduce our speaker before we request Dr. Madhu to give his presentation. So Dr. Madhu VR is a principal scientist at ICAR Central Institute of Fisheries Technology. A brief description about Dr. Madhu. He joined ARS in 2003 and was posted in Wearable Research Center of ICAR, CIFT, in the Fishing Technology Division. He worked at Wearable for close to 7 years, and he continued his association with the organization, and now he is at the headquarters in Cochin. He completed his master's from CIFE in Mumbai, and he obtained his PhD from Jawaharlal Nehru Technological University in Hyderabad. And he worked on the topic characterization and quantification of bycatch generated by trawlers along Saurashtra coast of Gujarat. Dr. Madhu has received several awards. To mention a few, he was a recipient of POGOSCOR Fellowship in 2011, and he has undergone training at Plymouth Marine Lab at UK for understanding ecological indicators from satellite data for predicting fish abundance. He has been associated with Space Application Center and Indian National Center for Ocean Information Services for experiments related to development and popularization of potential fishing zones advisories. He is currently working on various projects related to sustainable fishing and quantifying fish behavior in the vicinity of fishing gears. With this brief description, I welcome Dr. Madhu on behalf of Nitte University. Dr. Madhu, a few seconds about my university. We are located in Mangalore. We are a deemed university, accredited as A+, and we are at the 65th rank in the country in NIRF 2023. Nitte University is primarily a health science university, but over the years, we have diversified into multidisciplinary university. We have various disciplines and various programs under these disciplines being offered. And we at the Center for Science Education and Research are committed to interdisciplinary and multidisciplinary research and teaching. One of the thrust areas for us is also looking at contributing to the Sustainable Development Goals as set by United Nations. And as a university, what we do in these aspects through our teaching, research, extension services, and stewardship practices. So under these, our institution is primarily looking at the indicator SDG 14, and we have been involved at looking at how we can collaborate and contribute to activities related to conservation and preservation of life below water, and also to encourage and motivate researchers to take up research related to aquatic environment, aquatic biology, fish biology, and so on. Towards that, today we have been fortunate to have you speak on the concept of overfishing and the problems associated with it. And we are indeed thankful to you for your time and for agreeing to address all of us here at Nitte University. We do have audience from other institutions as well who have joined, and because it's an online event, it becomes easier for people to join from various parts and various institutions. A small request to all the participants, please keep your microphone muted at all times in order to avoid interference with the presentation. And Dr. Madhu, we will take up questions at the end of the presentation, either through the participants directly asking you or through messages on the chat box. With this brief opening remarks, I would like to request you to please take us through the concept of sustainable fishing. Over to you, Dr. Madhu.
Yeah, thank you, Dr. Ivan, for that introduction. It was quite good. I'm happy to hear that. I think you're also working in SDG 14. So specifically, in fact, if I can ask, like specifically, are you into the Marines, side of it, or anything related to that?
So, Dr. Madhu, we are looking at. So many of us have come from come with the fisheries biology and fisheries, background, fish and fishery science background. So we are looking into various aspects. We are not only looking at the environmental aspects, but we are into hardcore research pertaining to problems related to aquaculture, mariculture, fish, aquatic animal health, and so on. So there are plenty of activities. We are now trying to join hands with premier institutions like yours and the CMFRI and, of course, MPEDA and other agencies to embark on activities that can have a direct relevance to what we are doing at the lab level and take it to the field level. So just to give you an example, our colleagues, I think Dr. Biswajit is here, we just completed a project which is supported by Norway Research Council and DST from India. So we worked on the concept of probiotics and vaccines in aquaculture. So we did look into the possibilities of developing novel forms of vaccines and also looking at probiotic bacteria as an alternative to antibiotics. So we just completed that project. So we have quite nice, potential applications from that we can think of. So this is just one example to tell you. There are, of course, other group, Dr. Rajeshwari and Dr. Gunimala, they are my colleagues here. Dr. Ramya, Dr. Krishna, they are working on microplastics. So there are two groups. So one is looking at the microplastic effect on animal health, particularly the physiology part of it. And the other group, they are working on whether microplastics could be the substrate or hitchhikers for the bacteria to turn into resistant forms. Their antibiotic determinants are being transported by these microplastics in aquatic environment. So these are some of the just quick two examples that I give. And we are also, open to diverse areas of research as long as these are societal in nature and these are relevant in the long term.
Yeah, great. Yeah, thank you. So can I share my screen?
Please go ahead.
Yeah. Hope it's visible.
Yes.
Yeah.
Yes.
Thank you.
Thank you.
So I'll just start with the fishing, but mostly my talk would be concentrate on the fishing part. So we'll be dealing with what's the current status, both in the global and Indian scenario, and then we see that we have a lot of technologies, particularly in the early 20th century, where the fishing, in fact, which was an age-old practice, has transformed itself into the scale which we see today. And then also we look into what is the production, as I told, both the global and Indian scenario, and what has been the trends in these catches. So as we see here, this, as I told, was quite an old profession, in fact. So you would have seen, people, even if it's still, going on, with, people using very small equipment or without, anything like that, like just spear fishing and all, it's still there. But then over these years, what you see is that these fishing methods, they got, into another level. They got into the other level with modern vessels with a huge net, with a huge engine, with a big vessel, and we have all these facilities on board also, so that the catch which is caught finally comes out as an end product. So this is like the transformation that has happened over these years. And if you see, the decadal changes in the production on a global scale, we see this in fact. So there are two aspects of it. One we have is the capture production, and another one is the aquaculture. So if you see this, the red colored, the highlighted figure, what we see here is that in the 90s it was close to 90 million tons, the total global production. And then we come, say the first decade, second, third, fourth, fifth, and again you see the catch is still 90.3 million tons. So not much of change over these years. And then on the contrary, if you see this, the aquaculture part, so it was around 22 million tons in the 90s, and then which has significantly increased to 87.5 million tons. So this is basically what's happening now, because with all this increase in the engine size, the vessels, and everything, and so much of sophistication happening in the fisheries, the capture side of it, hasn't improved much. It means that we have reached a plateau where further improvement would not be possible. But on another scale, we see that the aquaculture production from the inland waters is quite an increasing trend. And if you see the share of export in the total production, so that also has remained the same. So there are two aspects to it. One is that the per capita consumption has increased. And also another part is that the utilization. So the food use of the fish has increased. And concurrent to that, the non-food uses has also increased. And this is pretty much the same, what I put in the table. We see that the marine captures are, stagnating, that has plateaued from the 90s. And the aquaculture part, the aquaculture in the marine waters is increasing now. In fact, it's an increasing trend. And if you see the aquaculture from the inland waters, quite a significant rise, great increase in the production from the 90s. And this is best, the top countries which produce from the marine and the inland water captures. So China again topping the list, and we are in the fourth position in the capture scenario. And then when we come to the issue of sustainability, so what percentage of the fish that we catch are overfished or sustainably fished or underfished? So if you see the 1974 from where we have this data, so we see that only a small portion of is overfished, the yellow band which you see on top. But coming over to the right side of the graph, the unsustainable fishing of the stocks. This is basically the concept of fishery stocks. So these stocks, maybe there are thousands of stocks, but then many of them are in unsustainable level. In fact, they have decreased substantially. And also the underfished stock, that means which are below utilized, that was also significantly reduced. So this is in fact the from the FAO data. Like we have a publication called the SOFIA. I think most of you must have read it. It's, the state of fisheries and aquaculture. So they come up with this data every 2 years. So this is the latest figures that we have. So this is in fact getting data from the different countries and then collating. And also the inland capture is also significantly increasing, as I told. So we have in fact see the inland water capture. We have crossed the Chinese production in the recent years. The India is the second one, and then increasing significantly. And as I told, the fish and the seafood consumption pattern has also increased over these years. So we are close to now 6, but the average is around 20 kilograms per capita. And coming to the Indian scenario, the total production now is like around 16 million tons. And on the per capita consumption, the Indian scenario is almost 6.3. And we contribute almost 1.1% to the Indian economy, GDP. And again, the inland capture again contributing significantly to the overall production. So the value of exports is something like the recent figures is like around 64,000 crores. And the potential, like what we estimate from the Indian waters is 22 million tons, 5.31 from the marine side, and the inland is almost 17 million tons. So that's the potential that is estimated. And coming to, I thought like many of you are not from this background, I thought I would also, indicate what are the different methods, like what we use for capture of fish. Because we, just to highlight like what we do as an institution, we have two major areas of work research. One is fish processing aspects, and another one is the fish capture methods, the fishing technology. So I mostly deal with the fishing technology part, so how to make the fishing gear sustainable. So before that, like I will just mention what are the different methods that are used for capture. So this is just a highlight. The top portion is the trawls, we call it. It's a bag type of net where a vessel drags it. So this mostly behaves like a bag underwater, and so whatever comes in its way is get captured towards the end. So this is called the cordon. And this is an active method of fishing, we call it, because the fish are actively chased. So this involves a lot of fuel. And the lower portion is called the passive methods of fishing, where gill netting is very common one there. And you have something called the long lining operations, where you put a hook and also traps. So these are less energy efficient, less energy consuming. In fact, energy efficient they are. In fact. So also some traditional methods of fishing. You have this pole and line method, where it's widely practiced in Lakshadweep areas in Indian coast. And you have this long lining operations, and then significant use of lights also. And coming to each one of them, in fact, line fishing, there are different variations of it. Like you have this traditional long lining operations, pole and line, trawl line, and sorry. So with the hooks, we have different types of hooks: circle hooks, wide, gap, rush, EZ. So there are different hooks like we use for capturing different types of fishes. And another method is called the trawling, which has outrigger booms, and when from there you have different lines with a hook, so that fish is fishes chase this and then gets captured. And I was mentioning about the pole and lining operation in the Lakshadweep waters, where they carry baits, and then once they see a shoal of tunas, this is particularly for tunas, they throw this bait into the water, and then so it forms a melee. In fact, a lot of activity there, and then they also use unbarbed hooks there, and then try to capture the tunas. So this is like quite energy efficient method and widely practiced in Lakshadweep. And this is another method to capture particularly the tunas, long lining operations, where you have a huge or very large number of hooks hung on a main line, and the lines, the baits are used for the capture. It looks something like this. So this is a long line operation, and then you have branch lines here and the hooks which are baited and mostly used to capture large pelagic species like tunas, and many of these larger carangids. The issue with these hooks are that there are chance that the turtles, like which are ETP species, endangered turtle and protected species, they also get captured here. So what research we have done is globally also it has been widely used. Instead of the traditional hooks, they use the circle hooks. So what happens is that the normal hooks go deep into the the esophagus. So once like the turtle comes out in the deck, it's very difficult to take this out and to release them. But what happens with circle hooks is that it is shallow hook, mostly in the jaws. So it's very easy to remove that and then to release the animal back into the water. So this is again a bycatch reduction device, you can call it. And also, if you can see, in top there is something called Tory lines. These are basically used to reduce the capture of sea birds, because these birds have a tendency that since these hooks are baited, so once it goes, it's slowly released into the water. They come and get hooked. So there's considerable mortality happening. So these are Tory lines, which is which is normally used to distract the birds so that they cannot see this baits entering the water. So a lot of small innovations done to reduce or to make fishing more sustainable. And you have another method called gill netting operations. This is basically something like this. So this is I think most of you would have seen this also, like a wall of netting, which is put in the water, kept there for, it's called soaking, kept for maybe 5 or 6 hours. So that it's a very passive method of fishing, very low energy intensive method, where fishes gets gilled in this and then they are finally captured. And I think the most used one in this scenario is the trawls, where 50% of our catches come from trawls itself. So you see, this is, like I told, it's a bag type of net, where you have different types of operations based on how it has been used. You have 2 boats operating, 1 boat, and then beam trawls, then double rig trawls. And seine fishing is again widely used, where it's a type of personing is widely used, where you have something called, it becomes a purse like of thing, and then when it's basically used to catch shoaling fishes. They come in large quantities. So there's a purse line which you'll be able to close, so that it becomes a sort of purse, and the fish gets entangled here, the shoal gets entangled, and then finally they are caught and brought back. So this is widely used bulk catching, fish catching method, and different equipment used for that. And I think this one many of you must have seen in the Mangalore coast, the Karamadi they call, rampan or Karamadi, what they call in Kerala. So this is a beaching operations. When the shoal is located, it is they just cover them and then is pulled from the shore. This is again a very traditional method of fishing. And if you see on a global scale, the major gear which captures the most of the fish that we catch today is the bottom trawls, and second in line is the persines, and then you have another component, not specific, but then small scale fishery, because they contribute significantly, even though not in a large scale, but then small fishermen with the small boats with small nets contributing significantly to the overall catches. The issue that I'm highlighting here is that the bottom trawl, because bottom trawl, I think many of you must have heard that this is one of those gears which is implicated with huge damages to the ecosystem. So both in terms of capture of juveniles and also to the impact to the bottom, sea bottom. But then on the contrary, it is one of the widely used nets also, the gears. And if you see on an ecosystem perspective, the type of gears, and then what are their ecosystem effect indices. So the higher the score, the better, in fact. So some of them are highlighted in the red color. So you can see the stramellets. They are a type of gill nets, basically, with 3 walls. And the issue is that most of these which I've highlighted are the beam trawls or shrimp trawls or demersal trawls. They capture a lot of juveniles, and then energy efficiency, I told you, they spend a lot of diesel. In fact, the greenhouse emissions are quite high to capture a 1 kilogram of fish. So that I will come to that later on. So these are some of these gears that are commonly used and their ecosystem effect index. And if you see which is the best, I think if you have it here, this is the manually operated spear harpoon, and then pelagic trawl, and then persines. Persines are quite good because they catch in bulk. And in addition to that, we see that the size of the global fishing fleet has almost doubled in the last 30 years. So we have almost 4.5 million vessels now, and almost 65% of them are powered with an engine, and most, in fact, 3.5 million of them are in Asia. So this shows the enormity of the fuel use that we spend for the capture of fish, and also the emission part. And this is like in the Indian scenario, like how the progression has happened. See, in case of the upper one, it was non-motorized. Maybe in the 60s that formed the bulk. But then over these years, these numbers have come down. Till the last decade, it has gone very down. And then the blue colored line is the mechanized ones. Mechanized in the sense that there is a motor involved, and there is, there are, mostly it is mechanization has happened. In fact, number of fishermen have gone down. The work is mostly done by the machines. So their number has, increased quite fast. And that this is the major, gears now that have been used. So this is the classification that we have in our waters. So mechanized is almost 25% 0.8%, motorized is 58%, and the non-motorized is just 15.5%. And among these mechanized, you see the trawlers, they contribute around 72%. So the issue here is that the trawlers are the most energy consuming, and we have the most of them in our water. And also, I was mentioning about the carbon emissions, but we rarely think about this because once we buy fish, we never think like from where it comes from. So, but then if you see this, so for one ton of fish captured, these are the emissions happening from the different types of fishing gears. So for 1 ton of fish, we are almost emission is almost 3.52 tons in case of bottom trawling. But then that comes significantly reduced when it comes to the perceining. It is just 0.17. So although these figures are global scale, our emissions are much less when compared to the global average. That's what the semaphore data says. It is quite recently received. I think ours is around 16% less than the global average. So this is like, this is an old data, but then we have recent figures also. So ours is like 1.13, carbon dioxide release, tons of carbon release for 1 ton of fish caught, whereas in the global average is around 1.7. So one aspect of this, like I'll come to the sustainability aspect of the fisheries later on. One aspect of this is to reduce the carbon emissions. Like what could we do? So we could, improve the performance of fishing craft in here in terms of saving the fuel. So we should come up with efficient vessel designs which have reduced drag, thereby reducing the consumption of fuel. Then also energy efficient gears. Then there's something called energy size and right sizing of engines. So for a particular vessel, you have a specific vessel, specific design of gear and also the engine use. So that will significantly reduce the consumption. And use of bycatch reduction devices, because it reduces the overall drag, thereby reducing the fuel consumption. And also alternative energy sources like solar energy, and then alternative methods. Most of us, like, you have the steel vessels and FRPs, which are, if you take a LCA of that, so we see that they are quite high, in fact, because they are petrochemical based. So alternative materials for construction, at least partial replacement, also would significantly reduce the fuel that the what do you call it, the CG gas emissions that's happening in fisheries. And also we have also tried using satellite based technologies to reduce the scouting time. That means to search the fishes, we use a lot of diesel, but using satellite based technologies, the energy spent, the fuel spent for searching fish can be significantly reduced. And coming to the biological aspects of it, so we will see like what's happening in a global scale. So this is typically what happens in a fishery, in a stock. So we have this growth happening. In that we have this recruitment. So basically from here itself, the production, then recruitment. So these are the recruitment happening to the fishery, and we have natural mortality here. So that's natural, in fact, and this is the fishing mortality where we involve the fishing aspects of this. So there is to be a fine balance in all this. It's only then that the fishery stock will be sustainable. And when we say that it's not sustainable, then how do we know, like why it is not sustainable and what's happening in the fishery? So this work in Indian scenario is mostly carried out by semaphore. So they have this enumerators, not enumerators, in fact, enumerators in the fishing harbors, where they regularly go and check like what's the total catch coming up and what is the size of the fish that is there and whether it is increasing or decreasing. And then they take all these measurements. So say, for example, you have CPU is catch per unit effort. So maybe in 10 years before it was 10. And this is basically what's happening. So this is type of a sampling happening in the sea. So consider this as a vessel. So the CPU is 10. That means then unit effort, you may be having 10 tons. But then finally, after say 5 or 6 years, the CPU catch per unit effort is only 8 tons. So you see that there is something happening to the stock. So the stocks are declining. And coupled with this, they also, take length measurements, and then they find out like what's the trajectory happening, the growth, like how it is, moving forward. And all these, comes or goes as input into the models where they find out the maximum, something like the maximum sustainable yield, maximum economic yield, and everything. So that's the reason why, we tell that the fishery is sustainable or not, or whether it has gone beyond the maximum sustainable yield or not. So all these, it's all data intensive, and it's mostly done by, the by CMFRA in our conditions. And then, of course, in our conditions, like even though we have this maximum sustainable yield and then the maximum vessels possible, the effort is possible, but then, in most cases, the implementation is not, we don't have a quota system. Like in many of these European countries, they have a quota, like where they say, where the government stipulates that you can catch only 100 tons. So beyond that, it's not possible to catch. So, but then that type of, regulations are not there in our conditions. But then we have a set of other regulations where the basic idea is to decrease the effort. So that I will come over, the next slides. And also, apart from the reduction in the catches, what's happening is that we see that there is a change in the mean trophic level of species, because I think, like there's a sharks are higher in the trophic level because there is nothing that catches and eats sharks apart from other marine mammals and all. But what happens in the fishery is that we see that there's a gradual decline in the mean trophic levels. So that is also an indication of sustainability. It's just because that maybe we are catching. So what happens in a general fishery is that most of us tend to catch, most of the fishery in the beginning, we tend to catch higher value species, which are higher in the trophic level. Then finally, when their number reduces, they come down. So finally, it is the sardines and mackerels like we concentrate on, because they are large in number and then trophic level is decreasing. So this is in fact something called fishing down the marine food webs. It's a concept by Kohli. So he's a fishery scientist. So this is like also like what's happening in the fisheries in the Indian scenario also. So we even seen that over these years, our mean trophic level has gone down substantially, which is an indicator of sustainability. And we see from the latest estimates, we see that almost 56% of our stocks are within biological limits. So we undertake assessment of almost 52 stocks in India as per CMFRA data. So in that, almost half of them are sustainably fished. And coming to some of these issues with regard to the fishing operations as such, we have bycatch. So which is the catch which is not targeted. Like say if we are targeting tunas, so we have something called sharks also coming. That's called bycatch because we don't intend to catch them. Similarly, mostly in fishing operations, you have a target catch. Maybe it's pomfrets or maybe it is cyanids. But then you have a concurrent, incidental catches also coming, like which are mostly juveniles. You can see these figures. So the target catch is on the left side, but then what comes as bycatch is a mix of everything, where you have a significant amount of juveniles, which if allowed to grow, can fetch good amounts. And this is two-pronged thing. Like one is that we don't allow them to grow, and the second is that we lose a lot of economic value because we capture them when they are small. So this is a big issue mostly in the tropics because we have a large number of species with different length classes. So very difficult to control this issue of bycatch. So here you can see some of these figures from our vessels because we do a lot of work on how to reduce this bycatch in different fishing systems. See, these are juveniles. If they are these are skewed juveniles, if they're allowed to live for another 2 or 3 months, they would have grown to individual. I mean, to mature individuals. That's not happening. So this is something called, we call it growth overfishing. And if you consider, this is the recent figures that we have. We say that we almost 10% of our catches. We say that it's almost 90 million tons, the total catch globally from the marine side. So that is like almost 10% we have is bycatch. So significant issue. And then almost 46% of this is from the trawlers. So Indian waters, what we have seen is that if you catch 100 kilograms, almost 40 to 50 kilograms of catch is bycatch, mostly comprising of tuna.
Sir.
So I would like to highlight this also, because why this bycatch fishing is happening, because one of the inputs for the bycatch is this fish meal and fish oil plants, because they consume a lot of fish meal, untargeted fishes. So this basically goes as input to different poultry and also fish meal plants. So it's something like catching fish to grow more fish, particularly for the aquaculture. So if you see the issues faced, mostly it is the capture of juveniles. So bycatch issues is a growing concern, and then we have this growth overfishing. We are not allowing them to grow, and also we are capturing mature individuals so that the recruitment is not happening, so that new individuals are not coming into the fishery. So what happens is that there is a gradual decline in the catches over these years. And the second issue is high energy cost, the fuel use. I told you there are the vessel size is increasing, the fishing net size is increasing, and then the engine size is also increasing. So overall, like if you are catching 100 kilograms of fish, the same fish is being caught with the higher powered engines, which spend like 50 hours per liter or so. So there's a high energy operation that's become over these years. And also particularly with regard to some nets, like you have this bottom impact, particularly the trawlers, they affect the bottom also, so that the production is affected. And searching operations, I told, like it consumes a lot of energy. And then we have also trade barriers, like the capture of turtles, like particularly for the US, like the export of wild shrimp has been stopped because of the issue of turtles, because we have something called, they have something called turtle explorer devices. We do have that, and it's been I will show you some of the figures. Like they want it like that all the trawlers which operate should have a turtle explorer device, so that turtles are not captured during the shrimping operations. So these are some of these issues. Of course, management measures. We have code of conduct for responsible fisheries. We have a lot of international plan of actions for seabirds or bycatch, and then a lot of them in fact. So, but most of the issue here is the implementation part. That becomes difficult, particularly in a country like India, where we have multitude of fishes, multitude of fisheries happening, and then a lot of people involved. And if you come to policies, basically, is 12 nautical mile is the restriction where states have control over that. Beyond that, it is the state, the central government. So each state has its own marine fisheries regulation acts, so that they can implement based on the fisheries what's happening. And also with regard to legislations, we have this minimum legal sizes for fishes. I think it's slowly coming up. Kerala was the first to start, and then it is slowly. I think Karnataka has also started now, and we have all the states adopting an MLS. That means each fish has got a size, particular size, below which the capture is prohibited. So that is something that has come recently, which is quite found to be effective. And also the Marine Fisheries Regulation Acts asks for implementation of bycatch reduction devices. That means like some devices to be installed in the fishing gear, so that the number of bycatch that is caught is reduced. So you have a lot of them, and particularly most important one is the square mesh cordon, which is implemented by most of the states. That I will come to that later on. So we have also the seasonal closures, which is quite stringently followed in Indian waters, like the monsoon ban for fishing, and the total allowable catch, TAC it's called, but that's not there in Indian waters. And we have also a lot of marine protected areas, which are also areas which are one of the solutions for that. And some of these initiatives for responsible fishing in Indian scenario, like as a research institute, what we have done is, for fuel efficient fishing, we have developed a lot of fishing gears, which, when compared to the traditional vessels, they are quite energy efficient. So also we have tried the using solar energy as an alternative source of energy. so that the consumption of the fuel, I mean, the greenhouse gas emission is thus reduced. And also we have tried different gear designs. This is a design called off-bottom trawl, where this trawl, I told you it disturbs the bottom, but this design is a design which operates a bit above the ground with the traditional setup itself, so that the impact to the bottom is much reduced. And I was mentioning about the square mesh cordons. You can see here, this is the traditional diamond mesh down, and the upper one is the square mesh cordon. So when it is dragged, when the vessel is underwater, this diamond meshes tend to constrict. So the gap between these meshes gets almost nil. But on the other hand, if you see the square mesh cordons, the mesh lumen, we call it, the space between the meshes, it is retained. So what happens is that the juveniles get a chance to escape out. So this is one of the responsible methods, and then this technology has been adopted by most of the states. And also there's a reduction in the fuel because the drag is much less when compared to these diamond mesh cordons. So that is one technology that is now widely being adopted. And you have something called grids. So this is a typical trawler where finally, if you can see my mouse, this basically is the cordon where all the fishes get accumulated. So this is in fact kept in just before the cordon, so that this particularly for whatever you don't want to include, this one gets escaped to an opening. So this is so another BRD that we have used is the big eye BRD. So it's a small opening or in the cordon so that juveniles can escape out. And another BRD that we have developed in CFT. This is a juvenile fish excluder and shrimp sorting device, which in fact is a grid type of BRD. So there's a inherent sorting effect happening. Like shrimps will go to the lower part and then fish will be in the upper part. So the sorting is much reduced, and also the mesh sizes are quite big, so that based on shrimps, you cannot use bigger mesh because they'll escape. So you have different mesh sizes on the top and bottom. And this is like I was mentioning about the turtle explorer device, because many of these countries, in fact, particularly the US, stipulates that you should, so every trawl net, shrimp trawl net should use a turtle explorer device, so that no turtles, in fact, are getting harmed during this fishing operations. So it looks something like this. So whenever a turtle enters a net, so there is a grid here, and then it hits this grid, and then there is an escape hole flap on top. So this is in fact remains covered. So once a turtle hits this, so this gets opened, and then the turtles can go out. So you can see in this figure. So this is in fact a bycatch reduction device, and then we are actually renovating it now with the help of Empeda. And then it's going to come, we made mandatory in all trawlers recently. And also different BRDs for bag nets you have used for Hilsa particularly, because a lot of Hilsa juveniles have been caught in the bag nets when operated in the Hooghly. So we have been asked to find a solution for this, and then we have used this square mesh window type of BRD, which significantly reduced the Hilsa juveniles captures. So I was mentioning about the C hook and J hook. Those are significantly reducing the throat hooking. And different designs of shrimp trawls so that the juveniles can escape out. And also there are incidents that again many of these countries are very particular that marine mammals should not be affected when doing the fishing process. So we have issues with particularly dolphins in the Indian waters. And so we have tried pingers, so which is basically a device which emits sound of a particular frequency, so that dolphins, when they come near the fishing gear, they just they get alarmed with the sound and then move out. But we have issues with this also, because they are very intelligent animals, and then they get accustomed to this sound. So so it's trade-off. Like we need to continuously innovate to make this device to emit different sound waves, different frequencies, so that they can be kept at bay. And also the satellite-based technologies. So this is some of our work. Basically, the fish abundance is determined by the temperature, chlorophyll, and a lot of factors, but primarily due to the temperature and chlorophyll. So what this satellite technology does is that it finds out areas where the temperature and chlorophyll, they are conducive for the plankton to bloom. So if you could identify these areas using remote sensing, so we can give the fishermen a broad ideas like where your fish might be able. I mean, the possibility of fish could be higher in that area. So they can just go there and then capture fish. So what we have, the INCOIS, Indian National Center for Ocean Commercial Services. So they have been doing this study. So we have been collaborating with them. So what we have found is that there is significant increase in the catches, and also the scouting time, the searching time is also considerably reduced when using this. And they are, INCOIS is giving this advisories to all the fishermen along the Indian coast. And also something like, since I told the mean trophic levels, similarly, there is something called match-mismatch hypothesis, where the fish larvae, the recruitment is happening with the peak of the plankton bloom. So with this, we can time, like we can also predict whether the stock is, that particular stock is quite good or not. So these are some of these technologies that can be used. And also we have, it's widely coming up, we have these certification schemes. So there are different, agencies that do this. In fact, it's quite a talk now, because a lot of, fisheries, I think many of them, in fact, in the Indian waters are also into this scheme, because at least there is, some type of control and then assessments happening, because in order for a fishery to be certified, there are a lot of barriers. So once we fill, or once we can mitigate these shortcomings, then definitely the stock status also will improve. And with regard to other resources, like we have microphytes, krill, and oceanic squid, which are not much exploited, but there is a potential, a huge potential if this could be utilized. Some initial works have been carried out by CFP and CMFRA, but I think it has not come to a fruition now. So what what could be done to make fisheries sustainable? One is, the main thing would be to reduce fishing effort. That means we have almost 3 times the vessels that is actually required to capture these fishes. So we have a stock size. We have a potential, say 5 million tons. But then for the capture of that, we may require only 100 vessels. But then we have now almost 300 vessels, almost 3 times the vessels that are actually required to capture these fishes. So what happens is that the overexploitation happens, overfishing happens, then you have high energy use and all those things. So the first thing to do would be to reduce the fishing effort. And then something called live fishing, low impact, fuel efficient fishing. So even though we have a large number of fishing gears, one thing would be to reduce it, but then we have something called a low impact, fuel efficient vessels. So with all those, like what I have told, like bycatch reduction devices, gear restrictions, technical measures, seasonal closures, and everything. So we could in fact make it more sustainable. And management is something that is very, very important, both top down. So we have regulations, and then implementation also from the bottom up, like fishermen themselves taking up this, this job, because it is basically their responsibility, also their bread and butter. So and also the ecosystem considerations. And we seriously require this energy audit, because the carbon credit and all, they're coming up in a big way. So whatever operations we take up, so there should always be an energy audit. So what's happening? Like, say, if I'm using this type of net or this type of gear, like what's the energy use? So energy is the king now. So that should be implemented in all these activities. And total allowable catches. I don't know how far it would be effective in Indian waters, but then that is one of the suggestions, like I would put forward, catch limits. And also the data consistency, because we need to in fact use the lot of data that's coming up and as an input to the model. And effective use of remote sensing, because we're quite good in remote sensing applications, and then effective use of this will significantly improve our fisheries, mostly in reducing effort and also to make it more greener. And also if you could get more more revenue or more money out of a particular as what we're doing now, like let's say we are removing out the middleman in terms of digital marketing and everything. So definitely that would improve the income of the fishers, and then by would have an effect on the effort part, and also significant cooperations both internationally and nationally. And then to just an outline of like what had happened over these years. This is from the Sophia report itself. So this is quite an interesting slide. Like fishing started in 1860s. Then you have this industrial fishing coming up, and then the World War, and then significant improvements in the vessel and also the navigation aspects. And then so this lighter color is high impact. The lower impact is this lighter color, and higher impact is this reddish tinges. So we see that efforts to slow down pressures have only started maybe in the late 80s. The green line you see it. So then you have all these SDGs and everything coming in very late, in fact. So but then that has definitely given it was an eye opener, and then a lot of things coming after that. The UN conference, maybe the Rio one, 1992. A lot of things happening after the late or early 90s. So I think I'll end with that. Thank you.
Thank you, Dr. Madhu, for the wonderful overview about the fishing. You started with historical perspectives, and then you went on to tell us about and what are the with other organizations you all are looking at managing this aspect in fishing. So we'd like to really thank you for the exciting and interesting insight into the things that we generally don't discuss or don't know much about. Although some of us have kind of got our memories refreshed because we studied all of this at some point of time, but then it was nice to come back and listen to the basics and also the applied aspects of it. So we will take a few questions from the participants. I think there is one question for you from Dr. Dikshit. He says, what would be effect of natural phenomena on fishing sector? Your comments on this, Dr. Madhu, such as El Nino, for instance.
Issues. I think that's what you would be hinting towards. Like that has caused significant shifts in the fishing aspects. Like the recruitment has affected. Particularly, I think I have not mentioned about the El Nino part, because we know the Peruvian anchovy part. It's quite significant. And then apart from that, the climate impact is the climate pressure. What's happening is basically in terms of recruitment and also the shifting of populations. Because one aspect what we have found in Indian waters is basically there is sardines. Basically, when if you see sardines were confined to the Kerala and maybe the Mangalore coast, still that. But now what we see is that it has started moving towards the north. And now you have this. Now you capture this large amounts in Gujarat also. So this is basically CMFR has studied this, like what's happening with this, because this is just there's a change in the temperature of the water happening. So that's the reason why it is going up. So when this fish starts moving up, so then there is a significant change in the fishing activities also. Because earlier, like you cannot find, maybe in 2000, maybe till 2010 or so, or 7, 8, you could not find a ring scene or a persine in beyond Ratnagiri. But now, like this has gone beyond that. So, and again in the east coast also, the positioning net to capture these shoaling fishes, that is again going up. So that is, definitely has affected. So when you say that, the fishing activity has changed, so there comes, significant socio-economic part also, because there is a conflict happening, because the traditional fishermen are opposing ring seaners because they capture their resource, they eat into their resource. So, this is like, it's interconnected. A lot of things happening. So definitely the natural pressures like climate change, El Nino, whatever, those are all interconnected, and this definitely has an impact on the fish stocks, and that would definitely affect the socio-economic fabric also. That's affecting.
Thank you, Dr. Madhu. We have one more question for you from Dr. Praveen. He is asking you, are there any success stories or case studies of regions that have successfully transitioned to sustainable fishing practices? Anywhere else in the world?
No, actually, there are a lot of success stories. In fact, I have just removed 3 or 4 slides like where our own institution has conducted success stories. One I can say is the Malvan region, the Sindhudurg district, southern Maharashtra. So we, in fact, the Maharashtra government, the forest department had a project from the World Bank where they wanted to, make the fishery sustainable, particularly the trawlers. So they called us so that the trawlers. So what we tried was with the trawlers initially. So we told them one thing was that there are not many trawlers there, and then what we did was we introduced. I mean, we conducted a series of workshops where we introduced these concepts like we have so many bycatch reduction devices, so whatever you're catching is not sustainable. So finally, they agreed to try our, one bycatch reduction. What they tried was the square mesh cordite. So finally, what we did was whenever you come up with a technology and tell the fishermen that this will reduce the bycatch, they immediately say that there's a huge economic loss happening. So that's the first thing they say us. So what we did was like we put a small cover on top of the cordite. So whatever is escaping out will be captured in this small mesh net. So these trials we carried out for almost 3 months, so that fishermen could see like what's escaping out. So when we did this, they realized that okay, this is not much of escapement, and only the juveniles are escaping. So what happened was ultimately all the fishermen, all the trawl fishermen, they got converted. In fact, they were using diamond meshes. They all came to square mesh products, and then there was a 100% adoption of this. So all the trawlers in this area started using this, and then it was a huge success, and it has come in a lot of praise for this. And then the Maharashtra government has also implemented square mesh products. That is no success story that we can tell. But then I was telling about the socio-economic part also. So maybe after 2 years, then I went there, and then I find that not many people are using it again. The reason why we asked is that the bycatch, what is escaping out, that is valued maybe 10-20 rupees. So the fishermen are not basically from that area. So the owners are for diamond mesh because they have a reduced fuel consumption. The catch is quite good. The quality of catch is good. But then this bycatch, that is used by the workers who are from different internal regions. So they use this. So they don't have an account of this. So owner doesn't know like they are keeping this. So they take this money. And then what happens is that many of these are not willing to use diamond square mesh products. So they finally came back because owner has to run the show. So it's like even though if you have a technology, so the economic aspects also come into picture unless there is no strict implementation.
Right. Thank you. I hope Dr. Praveen is okay with the explanation.
Yeah.
I guess. Okay, he has already thanked you. Okay, then there is one more from Dr. Krishna Kumar. He's asking, are there any socio-economic implications for Indian fisheries communities when you are transitioning them from an unsustainable to sustainable fishing methods? I mean, probably in continuation to the example that you gave
Yeah.
Challenges that you could face as implementing authorities. That you said after 2 years you went back and you didn't find them actually keeping that adoption in place. And so how do you, probably that's the question he is asking, Dr. Krishna.
Yeah, definitely there is an economic aspect to it, because whenever there is a use of a sustainable fishing, there is definitely, apart from the bottom impact, so there is not much of loss happening. But then if you use any other sustainable fishing method, so definitely there is a small, it's something called short-term loss but long-term benefit. So that's really what's happening. But then if we can mitigate this with can come and implement a scheme where, okay, if you are using this, I'll give you a subsidy. But if you're not using that, definitely not. So in that way, in fact, it can, this can be done to a certain extent. That's what my feeling is. But then definitely there's a short-term loss, because if you consider because this, each fishing unit is each fisherman, so it is his livelihood. So if there is a loss happening, definitely he won't be doing that. Even the loss is very less, he won't be using that. But then definitely for an economy as a whole, for an ecosystem as a whole, it's like I am a person who is going to implement this. I want all the people to use a sustainable method. But then as an individual, he's not. So it's only then where we can come up with subsidies, or then some incentivizing. That's what.
Right. Yeah, I think quite interesting. There could be many other questions coming up, but then due to positive time, I think we should not keep you waiting for long. I have two questions for you.
Yeah.
And that is linked to one of the earlier slides that you showed, and towards the end you talked about the measures that are put in place. So my first question to you is, if you look at the statistics that you showed in one of your earlier slides, where you looked at the production from capture fisheries, more or less it remained constant. I mean, it started at 89 million metric ton and then around 92, 91. So over the years, it has remained constant. So do you think it is balancing it out, that in one way there is a bit of overfishing happening, in other there is probably a little bit of compensation happening? Or is it that the data that we're getting is not, cannot be generalized for the entire the ocean area that is being covered? Or what is your take on that?
No, I think, yeah, very good question, actually. In fact, the plateauing part is basically to the carrying capacity. That's what I feel. And if you read this concurrently with the aquaculture growth, because what we see here is, maybe 90 million tons is the marketable fish, which is being, used, human consumption or whatever, exports. So, but then there's another equally important fraction which is not being taken into account. That is that bycatch part. So in order to feed the aquaculture industry, the fish, basically the animal protein has to come from the bycatch. So definitely, I think that's the reason I think we are missing the link. So that's basically what you call fishing fish to generate more fish, the aquaculture part. But then the issue here is that the amount of energy we spend for aquaculture and for fishing. For fishing, maybe it is like say 1 ton of carbon dioxide for 1 ton of fish. But then when it comes to aquaculture, maybe it is 5 or 6 or 7 tons of carbon dioxide for 1 kilogram of fish. So that's the difference. So that's what like we need to highlight, put it in the psyche of people, the population. So it's not like that aquaculture is a must, but then equally important is the poor man's source of protein, or the rich source of protein, which is captured in very less amount of energy. So energy, as I told, that's the king now.
Yeah, that is quite understandable. And actually, that brings me to my next question. In the last part of your presentation, you mentioned about the policies that are in place, the measures that are in place to bring about how to bring about sustainability in fishing. And one of the points that you mentioned is reducing the fishing effort. Now, the reduction in fishing effort, will it not negatively impact the livelihood of the people involved, because there's a significant amount of people who depend on on the fisheries as a primary source of income. And the second thing is the fact that we say, I mean, the argument that goes for aquaculture is that capture fisheries is not able to meet the demand of fish, and that's why aquaculture needs to step in and compensate for that increase in the demand. So how do you look at that in terms of so are you advocating that we go in for, if I can use the word, green fishing, keeping in mind the energy consumption, keeping in mind the emission of GHGs and all of that? If that comes into picture, so is it not contradicting with the notion that more and more people should eat fish, and the fish is a better source of protein compared to other forms of animal meat? So what is your take on this?
Yeah, with regard to your first question, reducing effort. So definitely, there is something called a technology creep happening in fisheries. So maybe say if the old data is like we have 3 times the vessels that we have now presently operating, but in actual conditions, like most of these vessels have stopped operating because they are closed. So with regard to the technology creep happening, so say if my vessel is 10 years old, so I have a fishing capacity of 1. So what's happening is that over these years, I change my engine, which was 100 HP to 150 HP, and I increase the size of my gear, so which was like 30 meters to 60 meters, so it's double. So what happening here is that the fishing capacity. So if I have the capacity to capture 10 tons, my capacity to capture increases to 15 tons. So, but that is not accounted anywhere because we consider this as a vessel. So, okay, you have 100 vessels. Okay, you have 100 vessels. But then in actual conditions, in actual conditions, the capacity in fact has increased twice or thrice. So that is one aspect. So we need to, so as an institution, actually, we have actually advocated that there is a particular length to, engine ratio. So if you have a particular length plus vessel, you have to use only this. It's only then it's effective. Otherwise, what happens is that it's unnecessarily overpowering the engine. You use more of fuel.
Okay.
That's what. And definitely there is, like, if you have some stringent steps taken, definitely it will be affected. It will affect the livelihoods of people. But then most of them, the traditional sense of, to take it, particularly in many of the states, in fact, like in Kerala, if you see, many of these fishers, except for the perceining and reseeding, which are traditional operations, most of them are from outside the state. Like, they come from very interior parts of states of India. Then they're not actually fishermen. They want just a job. So at least if they don't find this, they will go to another. I think it's the same thing all over India, except the traditional methods of fishing. So definitely, we need to take a call on this. So I think this would actual fishermen, and if you follow these regulations, and then I think actual fishermen are not going to affect it much.
No, I mean, yeah, it's quite clear.
And then the second one, sorry,
the aquaculture, how you bring it about the aquaculture.
That's a tricky one, actually.
Because we keep hearing that, and there are a lot of issues with aquaculture as we.
My take would be that, you have different sources of protein for aquaculture. Say you have plant-based sources, soya, many things. But then what my take on this would be, as a research institution who's working on responsible fishing technology, is that, okay, you use a bycatch reduction device, which is stipulated by the government. And as a research institution, I know that if you use a bycatch reduction, there is no 100% reduction in bycatch. I can say that it's only 60%. So the other 40% is, incidental catches, which cannot be avoided. You cannot do that because underwater we really don't know like what's happening. The sea is complex, the fish conditions are complex, the fish behavior is complex. So I will say that maybe 40% or 60% reduction, 40% of bycatch I have. So that could go to the aquaculture industry. But then, of course, I am saving 60% of the other. So in association with the effort and also the regulations with regard to gear, engine, and everything, I think whatever is coming as bycatch, it could go to aquaculture. But then I think that is enough to feed the aquaculture industry.
Okay. Just out of curiosity, in some countries like Japan, they don't throw anything back to the sea. They virtually eat everything that they bring, and they do find and use some way or the other. But in India, we know that there are a lot of things which do not sell, even as a bycatch. So when they bring such amount of such a huge amount of bycatch which does not get used, do you think whatever they catch, or I don't know how it is right now in India, but for example, I mean, when I was studying, I think it is even true even now that the ribbon fish, for instance. Dr. Madhu, are you there? We were talking about the bycatch. I mean, in India, do we use everything that is collected in the sea, and or are there anything that is being thrown away? How does it work in India?
Yeah, we don't have such regulations. Like as you correctly told, like in Japan we have that, and European Union also has no discard policy. But we really don't have that. So in our situations, like we have, bycatch is divided into two. One is like incidental catches, which when bought to the shore has some value. Maybe they'll get 1 kilogram for 20 rupees or so, which mostly caters to the fish meal industry. And then second one is the discards. But in discards in our condition is mostly the seashells, then jellyfishes and all those things. So we have discards, but there is no policy as such that everything has to be bought this shore.
Okay.
But then this is one issue like we find because we really don't know like what is the total capture. So there is another issue.
All right. Okay.
Yeah.
Okay. Right. So yeah, I think there is one more question for you from Dr. Dikshit again. I think it is similar to what we just. Okay, his question is very simple. Is there a difference between a bycatch and a trash fish? Squilla, because squilla is usually considered as trash. So he's trying to understand, is there a demarcation between what you consider as a bycatch and what you say consider as a trash, which does not even qualify as a bycatch? Is there something?
Yeah. I think I just mentioned before that bycatch is something that we don't intend to catch. The target catch and bycatch. So bycatch is again divided into two. One is that incidental catches. So that's basically the trash, the incidental catches, something that is brought to the shore, like squilla. So the other one is discards, which doesn't have any value, like for jellyfishes, in fact, or maybe shells, so which doesn't have any value.
Yeah. So I think these catch that comes as unintended, of course, but then they could be utilized for many other applications from marine sources. For example, not only for consumption or not only for fish meal production, it could be for extracting a lot of bioactive compounds and things. Yeah, I think that could be one way of looking at it.
One issue with here is that once it is because this is such a huge potential for bioactives in this case, because it has to be preserved also. But what's happening here is that like say for jellyfishes, or maybe for other species like in many other countries which have high bioactive components supposed to have. So what they do is fishers, once they find that it is low value, it's called high valuing. So they just keep it aside, maybe on the deck. In Gujarat, if you see, there are maybe 2 or 3 tons of fish as such laying on top of the deck without icing anything. So the entire thing, like the purpose, like at least if you save half of that with ice, so and get transferred to institutes like you where you work on bioactives. So it's such a huge, thing. Yeah.
So many things could be.
Yeah, correct.
Yeah.
It's a huge way, in fact.
Exactly. I think we should make some efforts towards, preserving those valuable things that come and which perhaps have no value for the fisherman, who is more concerned about the target
immediate catch
and the bycatch. Yeah. All right, Dr. Madhu, thank you so much once again for your time, first of all, and for taking us through this wonderful topic on fishing. Again, on behalf of everyone here at Nitte and Center for Science Education and Research, I profusely thank you for this lecture. It was very informative and very enriching for all of us, and I'm sure we will have opportunities to have you again address us either in person or through online in future. If there are opportunities, I hope you'll accept our invitation again. And we look forward to having you in person sometimes in Mangalore. And if you do visit Mangalore, please let us know. We'll be very happy to welcome you to Nuxur and maybe introduce you to some of the things that we are doing here as a research institution. And perhaps if there are some overlapping areas that we can think of working together, it would be an honor and privilege for all of us here at Nuxur. Thank you once again from all of us. It was really a nice interaction with you.
Yeah, thank you very much, Dr. Ruban, for giving this opportunity. And also, I mean, I told you, like, we are a group which work on the fishing aspects, but then we have equally, we have a biotechnology.
Okay. I think he just emailed me. He's unable to join. So anyway, we'll end the meeting here. Thank you everyone for joining in, and we have one more coming up tomorrow. So please do take part in the next webinar, which is scheduled to be. Thank you everyone. Girish, you can stop.